Now I'm going to talk about the static keyword. You may have seen this if you've been following our other tutorials. This little keyword here called static. What does that mean? What does it do? And why should we use it? So let's take a look at this example here. I'm just defining 4 video game objects here and calling the constructor with 3 parameters. If I look inside the video game class, it just has 3 private fields. Here's the constructor that sets the private fields, and I just have an example method here that returns the title, and just an example property here that just gets the publisher. So very basic. So if I have a class like this, for example, how would I perhaps keep a tally of the number of video games I have in my collection? This is just an example. What I could do, every time I instantiate the video game class, I could keep track of a counter. And this counter can keep a tally of how many video games I have in my collection. So I initialize a counter to 0, and every time I create a video game, I can increment the counter by 1. So I could do something like this, for example. And that would work perfectly fine. But it doesn't look very elegant, does it? Not only that, but it doesn't really follow the principles of abstraction very well. We'd like to kind of keep this counter maybe hidden away in the video game class, for example. So how would we achieve this? Like, how could we do this? If we set up a counter inside this video game class, for example here, and then in the constructor for that class, I increment the counter by 1. However, the problem is this counter will belong to each instance. So if I go over here, and from game 1 I can access the counter, but it's only going to have a value of 1 because the counter belongs to each separate instance. So how do I kind of have like a global counter? Something inside this video game that keeps track of the number of instances of this class that we create. Now this is where the static keyword comes in. When we use the static keyword, we can use it on constructors, we can use it on fields, we can use it on methods, and we can even use it on the whole class, for example. So for example, if I define this counter field as static, then this field will be shared across all of the instances which have been created from this class. So it's a class level field. So anything with static inside the class will belong at class level and not instance level, like here, for example. So let's take a look at an example of this. So every time I create a new video game here, I want inside my constructor here to have a counter that increments by 1, and this will keep a tally of the number of video games in our collection, for example. So what I could do, I can just do a sample line here that writes to the console how many video games we have in our collection. So every time I construct a new object of the video game class, I'm incrementing the counter, which is static, so it's at class level, by 1 each time. And then I'm outputting a message to the console window that just expresses how many games I have in my collection. So when I run this program, every time this is constructed here, because we're creating a new instance, the counter is going to increment by 1 each time. So let's take a look at that now. So you can see here, it's incrementing by 1 every time. So this counter is being shared by all of these instances here. So it's quite clever how the static keyword works. What we can also do, for example, is have a static method as well. So for example, I can create a static method that gets the result of my counter. So let's take a look at that instead. I'm going to remove this line here for now. I'm going to create a static method. So what this method does, it just returns the counter, and it's a class level method. So that means we access it from the class and not an instance. So let's take a look at that right now. So if I go into the main program here, if I go to game 1, for example, now game 1 is an instance, so this method will not appear in this list. You can see there's no getCounter method here. That's because it's at class level. So in this case, I would have to type in the name of the class. And then once I put a dot after the name of the class, these are all the class level members right here. So you can see this method here called getCounter. It's at class level, not instance level. And now we can get the number of video games in our collection like so. And if we wish to output that to the console, we can just copy that method here, put it right here, and then delete that semicolon. So now I'm going to run the application. You can see we have a similar result. It's just getting the grand total of the number of the video games in my collection. And I appreciate I've just spelled collection wrong, but nobody is perfect. So that is an example of a static method and also a static field in C#. So perhaps this static keyword that we've been seeing in all of our tutorials so far is starting to make sense now. Our main class here is called program, and by default there's a method called main which is static. So this main is a class level method, and by default it's the first method that gets executed when the program is run. So if I create a new method here, for example, so I've just created a method just like this, and I attempt to call this method from main. So this is a static method. This is not a static method. Watch what happens. So you can see there's a red line here, and if I hover over that, it says the object reference is required for the non-static field or property program test. That's because we're calling a non-static method from a static method, which is not allowed. Because if something is not static, then it is an instance level method. Because we're inside a static method here, there's no instance to operate on. We haven't created an instance. We're not within a method of an instance. So there's nothing to do with instances going on here. We're inside a static method, but we're trying to call an instance level method. It's not going to work. So in cases like this, you would have to create an instance. This is just an example anyway. I wouldn't recommend you create an instance of the program class, but it just helps my explanation here. So once I put the instance before this instance level method, you can see the error has been resolved, because anything that's not static should belong to an instance. It's at instance level. What we could also do instead of that is just mark this method as static. And that way we're calling a static method test from another static method, which is perfectly fine. So one other thing we can do with the static keyword is to mark an entire class as static. And what we do, we take the static keyword and put it next to the class definition right at the top here. And when you do this, everything inside the class here must also be static, because if you define this at class level, then it implies that everything within must be static. So this is why all these errors are appearing here. But the main important thing about marking a class as static is that we cannot create instances of static classes. They are abstract and sealed implicitly. If you remember an abstract class, you can't create an instance of it. And if you remember a sealed class, you cannot inherit from it. So this is implicit. This is why we have all these errors here when creating a new instance. So we can no longer do this. Let's take a look at turning this class into a purely static class. So strap in and buckle up. Let's go. So all of these private fields here must be static. Now our constructor in a static class, it must be static, but static constructors cannot have access modifiers, so we cannot have public there. Also, it can't have parameters, so let's remove those too. Also, this keyword is irrelevant because this is only to do with instances, so that has to go too. Now all our methods and properties must also be static, and that should about do it. So this is an example of a static class right here. Now you may be wondering, well, if I can't instantiate this class, then how is this constructor even called, for example? What's going on here? Well, by default, when you run the application and access this class, This constructor is executed by the runtime environment once. So this will get executed automatically one time. So anything in here in the constructor, the static constructor, should initialize any variables or anything you want to do. That's the purpose of a static constructor in a static class. Now, if we come over to our main file here, so you can see we can't create instances of the static class. We can only access things at class level. And now I've marked everything as static, the properties, the methods. This is how we pretty much refer to the class. We put the class name like before, and then a dot. Then we can access various things here. And now, because there's no instances for this class, all of these members will exist one time, because that's the point of static. So we can set a publisher and access that. And also we can get our video game count like we were doing before. It's no problem. And just to prove that the constructor is run once, check out this method here where I get the counter for the number of video games I have. I'm just going to duplicate this method so it's called twice. I'm going to put 2 breakpoints on here so the code stops when this line is hit. I'm then going to go inside the constructor and put a breakpoint there. I'm now going to run the application so you can see what happens. So now the constructor hasn't executed, but the break is on this line here, videogame.getCounter. If I step over this, you can see the constructor here is called. If I step over that, we get the counter, we go to the next line. And if I step over that, you can see nothing happens. So the constructor is only called once on this first line here, and it's ignored on subsequent calls to any methods that exist at class level. So I hope this made sense. It's quite a lot to take in, but this is the point of the static keyword. It's to put pretty much anything you want at class level. So the concept of instances in this case are pretty much ignored in that respect. And I gave you an example of how static constructors also work. And the constructor is called automatically just when you touch any method or member, and then it's ignored for any subsequent calls after that. So I hope this helped you. This is the power of the static keyword in C#.